Hello and welcome to part 4 of my Godot XR Tools tutorial series. In this tutorial, we are going to look at completing the gun implementation we started in the previous episode. You can make this as simple or complicated as you choose. I've added a number of extra features that are often found in VR games. We'll start with our magazine scene we created last episode. In many games, loading a new magazine into a weapon will increase or reset the ammo count for that weapon. We can do that with our gun setup as well in the code that triggers when a magazine is loaded. For this tutorial, however, we're going to keep track of how many bullets are left in the magazine. In order to visualize there are still bullets left in the magazine, we are going to show the bullets. In the previous episode, we already copied over the bullet mesh and added it in. We will just unhide it and then position it at the top of the magazine. We'll rename this bullet to bullet 01 and duplicate it to create a second bullet. With the second bullet positioned, it obstructs the view for any further bullets, which is fine. We'll hide these bullets as our magazine empties out. For that, we need to add some logic to our magazine and add a script. We'll give our script a class name so we can refer to the magazine class later on. We add a new variable to our script that keeps track of the number of bullets. This number will decrease as we load bullets into the chamber and fire them. We'll add a method that lets us check if the magazine has any bullets left. Next, we add a method that takes a bullet from the magazine. If we still have bullets, we simply subtract 1. And we call a function that updates our bullets. We implement that function next, and in here we simply show or hide the 2 bullets depending on how many bullets are left. Finally, we add a ready function that calls our update bullet function. The update bullet function is a little overkill in this case, as our take bullet function is the only place that requires changing which bullets are visible. However, in the future, we may want to spawn in empty magazines or reload magazines. Back in our gun scene, we now need to add logic for loading a bullet into our gun. You can do this automatically after the magazine is loaded and just decrease the ammo count every time you fire your gun. In VR, however, it's nicer to physically interact with your gun and pull the slide backwards. This will eject the shell of the last bullet fired and load a new bullet from the magazine. We want to visualize the bullet that is loaded into the chamber when pulling back our slide, or show an empty shell if it has been fired. To help us correctly position this, we'll add a mesh instance to our slide and call it loaded bullet. And we copy one of our bullet meshes to this new node. We'll move the bullet slightly up so it's centered on the barrel. Now we can see that when we move our slide back, it exposes the bullet. If the bullet was fired, we want to show just the casing. We'll make note of our bullet's position and then move it up so we can see it. To get the positioning right, we add a mesh instance as a child of our bullet and call it fired bullet. We'll move that up slightly as well and create a cylinder mesh. We'll size that roughly the same size as our bullet, and we rotate it 90 degrees. Now we fine-tune the size to match our bullet. We add a material to our shell, and we give it a color that roughly matches our bullet. We adjust the number of segments as well to match the shape better. We'll save the mesh for our shell so we can reuse it later on. Now we zero out our Y position to line our shell up with our bullet. Then we move our bullet back down into position. And we reparent our shell to our slide. Finally, we hide both our mesh instances for now. Now we can start working on the mechanism itself for pulling the slide back, ejecting any bullet or shell that's in there, and loading a new bullet. We start by adding a helper node to our slide. We'll call that slide pivot. We move it into place. We don't want this to be a child of our slide. We just did that to help us position. So we drag it to be a child of our root node. We'll add a pickable object to this node, but in this case we're not subclassing it. We call this slide pickup. We'll disable this by default because we only want to be able to interact with our slide when the player is holding the gun. We do need to add our grab points to this so our hands can be positioned correctly. We also need a collision shape. To get access to this, we need to enable editable children. Note that we are not going to add a mesh here. The mesh is our slide. We're basically picking up an invisible object. A simple sphere collision shape will do nicely. On our root node, we are going to connect our picked up signal. Before we implement this, we need to add an onReady variable that gives us access to our slide pickup node. This node will get reparented when picking up, so we can't rely on our standard notation here. We also add an onReady var to get access to our pivot. I'll also type our pickup so our code completion works. When our gun is picked up, we'll enable our slide pickup. We also connect our drop signal. We check if our slide has been picked up, and if so, drop it. We need to call drop on the hand that has picked up our slide. Then we disable our slide pickup. In our process function, we'll check if our slide pickup has been picked up so we can animate the slide. In order to figure out how far our slide is being pulled back, we need to transform the global position of our pickup by the inverse transform of our pivot node. We want to limit how far we can pull back our slide, so for this we'll create a variable called max pullback slide. We'll tweak the value a little later on. Before we move our slide, we also need a variable recording its starting position. Now we can calculate how far we've pulled back our slide by taking the negative of the z component of our pickup position in local space. We do make sure this does not become smaller than 0. Next, we check if we're still within our slide range and haven't reached our maximum yet. If so, we'll position our slide by subtracting our slide distance from our original position. Else, if we've reached our maximum, we trigger our reload sequence. We haven't gotten everything ready yet, so for now we'll make some notes of the steps we need to implement. We do end by putting our slide back into its starting position. And we drop our slide pickup. We'll add an enum to our script that allows us to record the state of our gun. We'll define unloaded, loaded, and fired as states. We then need to add a variable to hold the current state and default that to unloaded. Next, we'll handle the code to load a bullet into our gun. For this, we make sure our magazine variable is typed. If we have a magazine and that magazine has any bullets left in it, we'll take a bullet from the magazine. Now we change the gun state to loaded. We'll add a method call to a method that will update our bullets. Implementing this method, we simply show or hide our loaded bullets and our fired bullet based on the gun state. Now we can implement the eject logic. We start by checking if our gun state is not set to unloaded. If so, we call a function called eject bullet. We need to prepare some more things, so for now our eject bullets function simply sets the status back to unloaded. In order to eject our bullet, we first add a helper node to our gun that tells us where we spawn ejected bullets and in what orientation. In order to orient this helper node, we turn on local coordinates and move it into place. We'll eject it in the direction of up, our green arrow. We also want to place the spawn point outside of our gun's collision shape. Note that when we eject the bullet, our slide will have been pulled backwards, and our spawn point moves along with it. Next, we need a scene to spawn, so we'll create a new scene for this. This will be a 3D scene, and we'll change the root node to a rigid body. We'll name this casing and save it. We'll add a mesh instance for a bullet and for our empty shell. We can load the mesh for our casing that we saved before. We also need to rotate this 90 degrees. For our bullet, it's easiest to just save the bullet from our gun scene into its own resource. And we use that in our casing scene. Now we add a collision shape, and we'll use a capsule shape here that we size appropriately. As we don't want to fill our scene up with shells, we add a lifetime timer to our scene. We turn on one shot so it only runs once, and we'll auto start it. Now we'll add a script so we can implement our timer function. In this function we simply call a queue_free so our scene gets removed. We'll give it a class name, and next we add a function to our script that allows us to show the correct mesh. Back in our gun script, we need to add an export variable so we can configure the scene to use. And we assign our casing scene to our new property. We can now implement the spawn logic. We do this by simply instantiating the casing scene. We set our isBulletState on this. We also set our top level as true. This means our node does not take its positioning from its parent. We set our transform to the global transform of our spawn point. And we add it to our scene. Finally, we set its initial velocity based on the y vector of our orientation. Before we test this, we need to tweak a few small things I overlooked. We need to select the slide pickup and change the rigid body mode to static. We need to turn all layers in the collision mask off. I'll be turning the collision layer back on in a minute. Then, in our node tab, we connect the dropped signal so we can tell when the player lets go of the slide. Before we implement that, let's fix up all the issues in our gun script. We start with a variable that records the layer on which our pickup should be placed. Note that this is a bitwise flag, so for layer 3 we give this the value of 4. The next fix is in positioning our slide where I put in a double negative, so we remove that. Now that we have our drop signal, we can move our position reset into that function so it is called both here, as we're dropping the pickup, or when the user lets go. In our gun picked up function, we're going to set the collision layer of our slide pickup. And on our gun dropped function, we're setting it back to 0. Disabling the pickable object doesn't stop collisions. This may seem an error, but it makes sense for normal rigid bodies where we want to disable the pickup mechanism, but we still want the objects to interact with the world. In our slide pickup drop function, we also want to reset the position of our slide pickup. Here we can simply reset the transform and it will return to the position of our slide pivot. We also reassign our collision layer here, as our built-in logic can unset it. What we missed, due to our sidebar not being large enough, is that some of the higher up layers are also set by default. So we enlarge the sidebar and we see that we have more layers to unset, including on the picked up layer. Putting our slide pickup object in layer 3 causes a problem that our slide pickup can now collide with our player body. We want to use a layer that doesn't do this. To make life a little easier, we will select that layer here. We will choose layer 11. We need to go into our main scene and make sure our pickup functions are able to pick up objects in layer 11. We don't do this for our ranged pickup. We only want our slide pickup to work if we're actually touching it. We repeat this on our right hand. Back in our gun script, we start by increasing our max pullback slide distance. We remove the default value for our slide layer. And we add a ready function in which we assign the layer we set on the node and then zero it out. Finally, it turns out that we do need to assign our transform after we add our casing scene to our scene tree. And we need to specify a smaller multiplier for our initial velocity. So now, when we pick up our gun, we can pull back the slide. Yes, there are some clipping issues here, but that's good enough for this demo. Once we load our magazine, we can pull back our slide and load a bullet in it. If we keep pulling back the slide, we'll slowly eject all bullets. Once the magazine is empty and we eject it, we can see there are no more bullets left. Now that we can load our gun, it's time to make it shoot. We're going to add another helper node to indicate where we'll spawn bullets. We'll place that nicely in front of our muzzle. We're also going to add an audio stream player for our fire sound. We'll add this as a child of our spawn point to position it there, but move it back to the root. We've got a nice sound clip to add to it. When we shoot our gun, we also want to show a muzzle flash. I downloaded a nice asset for this from a free game art. We'll add a mesh instance in and drag our muzzle flash object into this. We'll need to scale this down and orient it correctly. We see that only one side of our mesh shows. We can solve this in the material. I prepared a material for this earlier on, and we can just drag this onto our surfaces. The material has the correct texture set, it is transparent, marked as unshaded, and has culling disabled, which I forgot to record. Now we can move it into position. Finally, we hide it. Next, we'll duplicate our fire sound so we can play a different sound if we try to fire our gun without a bullet loaded. Back in our gun script, we're going to add a method that we can call when a bullet needs to be spawned and a method we call to eject our bullet and reload a new one. We can move the code we wrote before into the second method so we can reuse it, and replace the old code with a call to this function. In any script inherited from our pickable object, we can add a method called action. XR Tools will call this function when the trigger is pressed on the controller holding the object. In this method, we check our gun state. If it is set to loaded, we are going to play our animation called shoot. If it is not loaded, we are going to play our animation called empty shoot. We'll also check at the start of this function if we're already playing an animation, and if so, exit. This effectively works like a cooldown timer. Now we're going to create these animations, and we'll start with our empty shoot. We start by animating our hammer and showing it strike our bullet. We create our keyframes first, one at the start and one at the end of the animation. Then we adjust our first keyframe to have the hammer move backwards. Playing this, we see that this is way too slow because I got the scale wrong. We'll increase our snap to have more control, and then move our second keyframe back. We'll also decrease the total length of our animation. Now if you play it, it looks much better. We also want to play our empty sound at the start of the animation. Note that I create the keyframe first, and then alter it to enable the sound. The sound keeps playing even after the animation ends. Perfect. Next we create our shoot animation. This will be a little more complex. We start with our hammer again and repeat the steps from the empty shoot animation. When the hammer strikes, we want to fire our gun. For that, we add a call track, and we insert a key that calls our shoot bullet method. Next, we create a keyframe that shows our muzzle flash. Because we created this keyframe with the muzzle flash visible, we have to make sure it's hidden in our reset animation. Before we continue, I realized I had forgotten to have our hammer primed after the user pulled back the slide. First, let's nicely set our hammer rotation to a round number on both our shoot and empty shoot animation. Then in our gun script, we add a line of code that moves the hammer to its prime position. Firing the bullet will also engage the slide mechanism, so we add a keyframe for this. Now for a neat trick. We can actually put a calculation into our properties and calculate the correct position our slide needs to move to. We actually can see that we need to fine-tune our max distance a little more, so we move our slide back. Now we add a keyframe for this. We move the timeline forward a bit more and move our slide back to its default position and create another keyframe. Now we can play our animation a few times and tweak the timing. We'll place another keyframe for our hammer where it's in its default position, and then add a keyframe at the end where we ensure the hammer is primed again. We also want to add a keyframe that turns the muzzle flash back off. Next we insert another key for our call track when our slide is fully backwards, and call our eject and load function. Next we want to play our shoot sound. This we reposition using our sample data as a guide. And we trim our animation so our effective cooldown between firing bullets becomes 0.3 seconds. Now we need to create a new scene for the bullets we are going to spawn. We create a 3D scene and change the type to rigid body. We'll call it bullet and save it. We'll add a mesh instance and create a sphere mesh to represent the bullet. Seeing how small the bullet is, the shape doesn't really matter. Next we add a collision shape and make this a sphere shape and size it slightly larger than the bullet. Just like with our shells, we add a lifetime timer to our scene as well. For this we need to add a script and connect our timeout signal and call Q3 on timeout, and that is our bullet for now. Back in our gun script, we'll create an export variable for our bullet scene. Then in our shoot bullet function, we'll implement the spawn logic. We can copy this from our shell spawn logic. Then we'll update the spawn logic for our bullet. Our initial velocity is now along the z-axis. And we change our gun state to fired. We also want to increase the velocity of our bullet. Now we can set our bullet scene to our new property. And with that, we have a fully working gun that we can pick up, load a magazine into, then prime and shoot. I've also included the bow that we built on stream into the project. You can find this on my GitHub page. If you enjoyed this video, please consider giving it a like. If you want to be notified of new content on my channel, please consider subscribing. It really helps me out. If you want to help me in a more direct fashion, please consider becoming a member. Many thanks to all my patrons and members for their continued support. That's it for this video. See you next time.